Good morning, everyone. Today I am going to explain the global maritime business and safety systems. This global maritime business and safety system, what actually EEE students they doesn't know what is the use of the global maritime business and safety systems. First of all, I am going to give some the introduction part about the on-board, what the steering system and the autopilot system and the bridge equipment, so that they can at least come to know what is the bridge equipments in the use of in on-board. Actually, global maritime business and safety system. This is the safety system which is used in a safety purpose in a on-board. Before that, I am going to give some introduction about the bridge equipment. So, what kind of bridge equipment is used in an on-board ship? First of all, gyroscope and steering system. Steering system is nothing but as we are used to bike steering and car steering, like that. In olden days, in a ship, the helmsman using the steering system in a manual. But nowadays, in a ship, in on-board, they are using automatic steering system, that is called autopilot. So that we fixed on a certain position to where the ship has to go, and we can move out from there so that the ship can move. So there will be a particular direction and navigation system also includes. And next come for autopilot system. What is the advantages of autopilot system is there is no not required for the manpower much. Nowadays, autopilot system they are used because of less manpower, and it is very useful for nowadays. So that once we fix the position in autopilot, the direction which have to be given, it will be move according to which direction we have set. And for next, we will go for bridge. I'll explain what is the steering system, or what and all engine is used in an engine. Two-stroke engine and four-stroke engine. Actually, the two types of engine which is nowadays is used in a ship. In ship, now we are now used in a two-stroke engine because two-stroke engine we used to run the engine in a on-board. I'll tell you which oil has to use for a two-stroke engine. Before nowadays diesel engine and the heavy oil usually used in run the ship, because diesel engine and heavy oil comparison between the diesel engine and heavy oil. Heavy oil is a very cheap oil, so that we can run the ship easily, and we can efficiency is also more, and we can run cost is also very less. Because of that, heavy oil we used to. Actually, basically the heavy oil is a thick oil. We have to heat that, and it will be like a flow, and so that we can run the ship very easily. Coming for this topic, because this is very important nowadays in ship, because global maritime business and safety system. See, nowadays in a ship, before days, in olden days, ship for example, Titanic. We saw in a movie, and we heard from some of the newspapers for sinking ship, those things. This is very helpful for who are worked in ship, who are working, who is going to work, and who worked. So, global maritime business and safety system, it is a internationally agreed upon set of communication protocols used to increase safety and make it easier to rescue distressed ships, boats, and aircraft. GMDSS, Global Maritime Distress and Safety. The name indicates it's a safety system. It is actually International Maritime Organization introduced for a safety procedure, and it's a communication like radio and media frequency, high frequency, so that we will communicate easily to the satellite, and it will come to the certain person as a radio officer. Suddenly we can take the action in a distressed ships. And next, GMDSS consists of several systems, some of which are new, but many which have been in operation for many years. Before the medium frequency system and EPIRB, there will be when you coming to the next EPIRB, many of the communication system has to be comes. So it will be used before in a ship system. And GMDSS, here GMDSS, this is alerting, including position, determination, unit distress, search and rescue. Maritime safety information. This is the all details about the information maritime organization. And recreational vessels do not need to comply with the GMDSS radio carriage requirements, but will increasingly the digital selective calling. So if the rescue happens in the ship, they can digital selective callings. They can on and say and VHF radios. They can call in offshore, and they can call the people to come and protect the ship. Since the invention of radio at the end of 19th century, the ships has to be in Morse code. Invented by, this is all invention purpose, in that nothing can be expressed. Come for the components of GMDSS. What are the main components of types of equipment used in GMDSS? First one, emergency position indicating radio beacon. This is the EPIRB. The emergency position indicating radio beacon is like what nowadays the policemen are using walkie-talkie. It's like walkie-talkie, and if you cast it and if you put inside sea, if you on that, then we can easily find out where the person exactly, and say the guards can save the person immediately. And the NAVTAX and USAR and high frequency and search and rescue locating device and digital selective calling. These are the main components of the GMDSS. I will explain one by one regarding this. Here EPIRB. This is the one of the components of GMDSS. See, this is the different. This is like walkie-talkie, and this is having some antenna. These are the several pictures of EPIRB. How it works? Actually, this is the SASA system of overview. Here, actually, this ship is going to sink, and this is called utilizing emergency beacon. Here, they will call for the distress call will be happen. It will be going to the second, the rescue. It will search the satellite where the exact when it happened. So it will be connect to the local user terminal. So that immediately they can it will go for a control section and a rescue coordinator center. This is the again it will be come back to the rescue coordinator center, and they will arrange some helicopter or something like that for safety purpose, and it will come back to the person who calls. So this is the one of the safety the components which is used in GMDSS. This is the same picture. See, this is the USAR satellite actually, and this is the local user terminal, and this is here the rescue coordinator center. Here, once the EPIRB they will put on, it will be activate, and it will be come to the EPIRB activated. It will come to the local user terminal, and it will be come to the satellite. Satellite will be used to find where the location exactly, and it will come to send to the local user terminal, and it will come to the control, and it will move to the they will send some safety provides, and where is the person exactly sinks. So they can easily help you out the person in a rescue position. Actually, what is the definition of what is the full form of EPIRB? It is emergency position indicating radio beacon. It is used to alert and search rescue services in the event of emergency. When an emergency, for example, if the ship is supposed to sink, but the person is already jumped into the water and he doesn't know how to save himself and he just put on the EPIRB. In emergency purpose, it will go to the certain satellite and it will find where the EPIRB activated so that the people can, offshore people can help the people safety. It does this transmitting the coordinate message on the 406 megahertz distance frequency via satellite and earth stations to nearest rescue. The thing is, there will be a coded message. They already fixed into the coded message. When the EPIRB activated, the coded message will send to the satellite, and satellite will send to the total rescue controller. And the controller, they will find out whether the EPIRB, where is the exact location the EPIRB activated, so that it will come to and help you out the people who are in the rescue position. And one more information. Some EPIRBs also have built-in GPS. It is have a global positioning system, GPS, so that we can find out where the EPIRB activated in the certain location, so that easily find where the person is. So which enables the rescue services to locate you to the 50 meters. 50 meters till we can find out where the location exactly it rescues. Who uses EPIRB? EPIRBs are generally installed on boats and can either be operated automatically after an incident or manually. In most countries, they are mandatory to be used to the for a shipping. How they used in some other boats also they can use in EPIRB. EPIRB, why? Because EPIRB is the most important component we need on board, so that it will be automatically set in on board. This picture shows how the person used the EPIRB. When he pressed the button, it will give you one alarm sound, so that it shows like it activated, so that the people can save him. Next, what is the differences between EPIRB and TLBs? Personal location beacons work in exactly the same way with the EPIRBs by sending the coded message for 406 megahertz distress, which is relayed via Compass Global Satellite System. The number of differences between them, but the main is this is a the personal location beacons and this indicating radio beacons have many differences. So that PLBs are designed to be used anywhere in the world, but EPIRBs we cannot. PLBs once activated will transmit minimum of 24 hours. But why the battery life of EPIRB is a double and minimum of 48 hours. So EPIRB nowadays is used because its battery life is more. And next come for it is EPIRB is registered in a vessel, whereas the PLB is registered to a person. A person. It means that if you are crewing, or if you have PLB by Asst or some other boats, we can use very easily. This is one pic of EPIRB and PLBs. This is the another component of GMDSS, Global Maritime Business and Safety Systems. ECDIS, Electronic Chart Display and Information System. Electronic Chart Display and Information System is another global maritime business and safety system. It is a computer-based navigation system. Computer-based navigation system that complies with the International Maritime Organization. It regulates and uses to alternative the paper nautical charts, so that IMU refers to the similar systems not meeting the regulations. Electronic chart systems. ECDIS system displays the information from electronic navigation charts or digital nautical charts and integrated position information, so that it will be actually the reference systems the topic navigational sensors, other sensors which would interface with the radar, graphics and automatic identification system. Next, I'll go for next. What is the applications of ECDIS? ECDIS provides continuous position and navigation safety information. The system generates audible and the visual alarms when the vessel is proximity to navigation system. Electronic chart data. The two most commonly used type of electrical chart are listed. Next, one is ENC charts. ENC are vector charts that confirm the requirement of the chart data of electronic chart display information systems. ENCs contains all the charts information. For necessary for the navigation may contain information addition. For the information may can be safely considered for safe navigation and can be displayed together in what seamless chart. Here the systems using ENC charts can be programmed to give warning of impending danger in relation, so that this is very helpful for one of the safety systems. This is another raster charts. Raster navigation charts are raster graphics. This is the charts come from IHO specialization and produced by converting paper charts to the digital image for scanner. Digital image by scanner. The image is similar to the digital camera. The image is similar digital to the camera pictures. We could be zoomed in a more detailed information, and it does in ENC IHO publications. So publication S61 provides guidelines for the production of raster data. IMO is the Indian Maritime Organization resolution. It permits ECDIS equipment to operate in a raster chart display system mode in the absence of ENC. This is another components of GMDSS, Global Positioning System. People already knows that what is GPS. Understand? And here the Global Positioning System is a space-based satellite navigation system. So that what is it provides the location and the time information in all the weather conditions, so that we can anywhere on near to the earth where there is a line of sight for GPS satellites, we can easily find out the location where the ship goes, where the ship comes, and we can exactly all the GPS settings is there in a controller, so that we can easily save and give the safety systems to the onboard people. The system provides the critical capabilities of military, civil and commercial users around the world. The GPS, the Global Position System, is not for onboard. It will be used for whoever there in a civil and for military and for commercial users also. This GPS is very, very important. Nowadays, for offshore, for example, in nowadays many robberies and many crimes are going in the world, so that this GPS is we can easily find out the location. For example, who is the one thief is take the mobile, so that we can by using this global positioning system, we can find out the location where the person is exactly with the mobile, so that we can easily find out here also the global positioning system in the onboard, so that where the ship is exactly moves. Next, the GPS project was developed in 1973 to overcome the limitations of previous navigation system. GPS is actually introduced in 1973 to overcome the disadvantages of previous navigation systems. So, integrating ideas from several predecessors, including number of classified engineering designs in the stock 1960s. So, GPS was created and realized for US Department of Defense, originally run with the 24 satellites. It became fully operational in 1995. For example, that 1995, this is all the scientists named Bradford, Parkinson, and Robert Asst, and even getting credited to the inventing it, which is called global positioning system. advances the technology and new demands for the existing have now to approach to the modernize the GPS system and implement next generation GPS third. Satellites and next generation operation control system. Announcements from the Vice President of this is and all theory about invented GPS and what is going to invent in advanced technology, and there also be planned European Union to Galileo positioning system. So India's Indian regional navigational satellite system, in Chinese it will call as a ground navigation satellite system. So this is the satellite in Earth orbit. This and all navigation system in global position we are used in a car and taxi cab and moreover daily uses. What is the come for basic concepts of GPS? A GPS receiver calculates its position by preciously timing the signals sent by GPS satellites high above the Earth. So each satellite continuously transmits messages that includes the time message was transmitted and satellite position and a time of message transmission. The receiver uses the message, it receives and determines the transit time of each message and computers to distract each satellite. So using the speed of light, each of these distances and satellites, the locations defines a sphere and the receiver of the surface, each of the the receiver is on satellites, locations are correct. The distances and satellites locations are used to compute the location of the receiver using the navigation equations. This location is to be displayed and latitude and longitude. There will be several elevation and altitude formation. So based on the high about this GMDSS. Basic GPS measurements in the position and neither these are the theories of global positioning system units that automatically to drive velocity and direction of the movement of two or more position measurements. So the disadvantages of this derived direction becomes straight like drops below the random error and the signals received from the computer accurately. The more advanced navigation systems are additional sensors like compass and inertial navigation system. Next, come for typical GPS operation, the navigation equations. What is the navigation equation? The four or more satellites must be visible to obtain the accomplished results. The solution of the navigation equations gives the position and receiver along with the differences between time kept by the receiver's board clock and true time based on the clock. Here, the four satellites are required for normal operation. Fewer apply for the special cases. In a variable already known, the receiver can determine its position using only in three satellites. For example, a ship aircraft may be known as elevation. Some GPS receivers may use additional tools of assumptions such as rescuing and known as attitude deadlocking and inertial navigation, or including information from the vehicle computer to give the position when the four satellites are visible. This is one actually visual example of a 24 satellite GPS constellation in motion. The Earth rotating. Notice how the number of satellites to view from the given point of the Earth's surface for 45 degrees and changes with the time. It's like a visible satellite. This is a ground monitor station used from 1984 to 2017 on display at the Air Force Base. I hope somebody knows, everybody already knows about this. This is the control segment. This control segment composed of the master control station and alternate the master control station and 4 dedicated ground antennas and 6 dedicated monitor stations. And the modern control station can also be accessed for US Air Force satellite control network ground antennas and monitor stations. Actually the 5 parts of the satellites are backed by dedicated of the US Air Force monitoring stations. These are all the scientists' name and so it will everything is written over there. Already I have given some explanation about global maritime business and safety systems. What are the components we are used to be like ECDIS, ECDIS, electronic chart display, and VHF, MHF, and the echo sounder. So that these are all the another equipments we use to in the navigation field in the onboard ship. Radar and GPS. Already radar is a navigation system and GPS is a global positioning system and SAT.com echo sounder. Echo sounder is used to find out the waves, the certain waves we can easily find out for the ship, and EPIRP is was indicating radio beacon and SAT and GMDSS, ship stabilizers and integrated graphics and electronic chart display. Next, radar is a system that uses electromagnetic waves to identify the range, altitude, and direction, and the speed of moving and fixed objects such as the aircraft, ship, motor, and vehicles, weather, the formation, and terrain. The term the radar was coined by 1941, and again for radio detection and ranging. It is the most important navigation system nowadays. It's used in the onboard ship. This term has since entered in the English language as a standard word radar using the capitalization. So the radar was originally called as RDF, radio direction finder. In the United Kingdom, the radar system has a transmitter that emits either the microwaves and radio waves that are reflected by the target to be detected by a receiver. Typically, in the same location of the transmitter, the signal returned is usually very weak. The signal can be amplified. So this enables the radar to detect objects at ranges where other emissions and sound and visible light could be also very weak in our detector. So come for what is radar. Radar is an object detection system which uses electromagnetic waves, especially radio waves, to determine the range, and the direction and altitude and aircraft, spacecraft, guided missions and motor vehicles, weather formations and terrain. So that this radar is used in as a bridge equipment on board. The radar dish or antenna transmits pulses of radio waves or microwaves in form of any object in their path. The object returns a tiny part of the wave's energy of dish or antenna, which is usually located at the same site of the transmitter. Here we come for a practical radar was when it is developed and what is the explanation of practical radar. Practical radar was developed during World War II by Britain and other nations. The term radar was coined in 1940. Already I explained about this, and by the US Navy and developed the radio detection and ranging. The term radar has since entered into the English and the other languages to common noun radar. So this is the one simple explanation like what is the before the radar calls the radio detection finding using the same acronym, one of the radio detection finding. So nowadays it is called as a radar. The modern uses of radar are highly diverse, including traffic astronomy and air defense systems and admission systems and nautical radars to locate the landmarks and other ships. Aircraft anti-collision systems and ocean survival systems, outer space survival systems, these are and all systems ground penetrant. Which is the uses of radar are highly actually diverse. ground penetrating laryngeological and observations. This is the long-range radar antenna known as used in detect and track space objects in a conjugation in a ATM system. This is the scientist name called Ronald Site on Quazalin et al. Radar components. Components of radar in a actually. This is an antenna and transmitter. Here we are setting and waveguide, and here the radar software and logical radar. This is actually user which is used in bridge equipments, bridge wheel in a onboard.